Edison, His Life and Inventions by Frank Lewis Dyer and Thomas Commerford Martin. Chapter 14. Inventing a Complete System of Lighting. In Berlin, on December 11, 1908, with notable eclat, the 70th birthday was celebrated of Emil Rathenau, the founder of the great Allgemeine Elektrizitätsgesellschaft. This distinguished German, creator of a splendid industry, then received the congratulations of his fellow countrymen, headed by Emperor William, who spoke enthusiastically of his services to electrotechniques and to Germany. In his interesting acknowledgment, Mr. Rathenau told how he went to Paris in 1881, and, at the electrical exhibition there, saw the display of Edison's inventions in electric lighting, which have met with as little proper appreciation as his countless innovations in the connection with telegraphy and telephony and the entire electrical industry. He saw the Edison dynamo, and he saw the incandescent lamp, of which millions have been manufactured since that day, without the great master being paid the tribute to his invention. But what impressed the observant, thoroughgoing German was the breadth with which the whole lighting art had been elaborated and perfected, even at that early day. The Edison system of lighting was as beautifully conceived, down to the very details, and as thoroughly worked out, as if it had been tested for decades in various towns. Neither sockets, switches, fuses, lamp holders, nor any of the other accessories necessary to complete the installation were wanting, and the generating of current, the regulation, the wiring with distributing boxes, house connections, meters, etc., all showed signs of astonishing skill and incomparable genius. Such praise, on such an occasion, from the man who introduced incandescent electric lighting to Germany, is significant as to the continued appreciation abroad of Mr. Edison's work. If there is one thing modern Germany is proud and jealous of, it is her leadership in electrical engineering and investigation. But with characteristic insight, Mr. Rathenau here placed his finger on the great merit that has often been forgotten. Edison was not simply the inventor of a new lamp and a new dynamo. They were invaluable elements, but far from all that was necessary. His was the mighty achievement of conceiving and executing in all its details an art and an industry absolutely new to the world. Within 2 years this man completed and made that art available in its essential fundamental facts, which remain unchanged after 30 years of rapid improvement and widening application. Such a stupendous feat, whose equal is far to seek anywhere in history of invention, is worth studying, especially as the task will take us over much new ground and over very little of the territory already covered. Notwithstanding the enormous amount of thought and labor expended on the incandescent lamp problem from the autumn of 1878 to the winter of 1879, it must not be supposed for one moment that Edison's whole endeavor and entire inventive skill had been given to the lamp alone, or the dynamo alone. We have sat through the long watches of the night while Edison brooded on the real solution of the swarming problems. We have gazed anxiously at the steady fingers of the deft and cautious bachelor, as one fragile filament after another refused to stay intact, until it could be sealed into its crystal prison and there glow with light that never was before on land or sea. We have calculated armatures and field coils for the new dynamo with Upton, and held the stakes for Gale and his fellows at the winding bees. We have seen the mineral and vegetable kingdoms rifled and ransacked for substances that would yield the best filament. We have had the vague consciousness of assisting at the great development whose evidences today on every hand attest its magnitude. We have felt the fierce play of volcanic effort, lifting new continents of opportunity from the infertile sea, without any devastation of pre-existing fields of human toil and harvest. But it still remains to elucidate the actual thing done, to reduce it to concrete data, and, in reducing, to unfold its colossal dimensions. The lighting system that Edison contemplated in this entirely new departure from antecedent methods included the generation of electrical energy, or current, on a very large scale, its distribution throughout extended areas, and its division and subdivision into small units converted into light at innumerable points in every direction from the source of supply, each unit to be independent of every other and susceptible to immediate control by the user. This was truly an altogether prodigious undertaking. We need not wonder that Professor Tyndall, in words implying grave doubt as to the possibility of any solution of the various problems, said publicly that he would much rather have the matter in Edison's hands than in his own. There were no precedents, nothing upon which to build or improve. The problems could only be answered by the creation of new devices and methods expressly worked out for their solution. An electric lamp answering certain specific requirements would, indeed, be the key to the situation, but its commercial adaptation required a multifarious variety of apparatus and devices. The word system is much abused in invention, and during the early days of electric lighting, its use applied to a mere freakish lamp or dynamo was often ludicrous. But after all, nothing short of a complete system could give real value to the lamp as an invention. Nothing short of a system could body forth the new art to the public. Let us therefore set down briefly a few of the leading items needed for perfect illumination by electricity, all of which were part of the Edison program. First, to conceive a broad and fundamentally correct method of distributing the current, satisfactory in a scientific sense, and practical commercially in its efficiency and economy. This meant ready-made a comprehensive plan analogous to illumination by gas, with a network of conductors all connected together, so that in any given city area the lights could be fed with electricity from several directions, thus eliminating any interruption due to the disturbance of any particular section. Second, to devise an electric lamp that would give about the same amount of light as a gas jet, which custom had proven to be a suitable and useful unit. This lamp must possess the quality of requiring only a small investment in the copper conductors reaching it. Each lamp must be independent of every other lamp. Each and all the lights must be produced and operated with sufficient economy to compete on a commercial basis with gas. The lamp must be durable, capable of being easily and safely handled by the public, and one that would remain capable of burning at full incandescence and candle power a great length of time. Third, to devise means whereby the amount of electrical energy furnished to each and every customer could be determined, as in the case of gas, and so that this could be done cheaply and reliably by a meter at the customer's premises. Fourth, to elaborate a system or network of conductors capable of being placed underground or overhead, which would allow of being tapped at any intervals, so that service wires could be run from the main conductors in the street into each building. Where these mains went below the surface of the thoroughfare, as in large cities, there must be protective conduit or pipe for the copper conductors, and these pipes must allow of being tapped wherever necessary. With these conductors and pipes must also be furnished manholes, junction boxes, connections, and a host of varied paraphernalia ensuring perfect general distribution. Fifth, to devise means for maintaining at all points in an extended area of distribution a practically even pressure of current, so that all the lamps, wherever located, near or far away from the central station, should give an equal light at all times, independent of the number that might be turned on, and safeguarding the lamps against rupture by sudden and violent fluctuations of current. There must also be means for thus regulating at the point where the current was generated the quality or pressure of the current throughout the whole lighting area, with devices for indicating what such pressure might actually be at various points in the area. Sixth, to design efficient dynamos, such not being in existence at the time, that would convert economically the steam power of high-speed engines into electrical energy, together with means for connecting and disconnecting them with the exterior consumption circuits, means for regulating, equalizing their loads, and adjusting the number of dynamos to be used according to the fluctuating demands on the electrical station. Also, the arrangement of complete stations with steam and electric apparatus and auxiliary devices for ensuring their efficient and continuous operation. Seventh, to invent devices that would prevent the current from becoming excessive upon any conductors, causing fire or other injuries. Also switches for turning the current on and off, lamp holders, fixtures, and the like. Also means and methods for establishing the interior circuits that were to carry current to chandeliers and fixtures in buildings. Here was the outline of the program laid down in the autumn of 1878, and pursued through all its difficulties to definite accomplishment in about 18 months, some of the steps being made immediately, others being taken as the art evolved. It is not to be imagined for one moment that Edison performed all the experiments with his own hands. The method of working at Menlo Park has already been described in these pages by those who participated. It would not only have been physically impossible for one man to have done all this work himself, in view of the time and labor required, and the endless detail, but most of the apparatus and devices invented or suggested by him as the art took shape required the handiwork of skilled mechanics and artisans of a high order and ability. Toward the end of 1879, the laboratory force thus numbered at least 100 earnest men. In this respect of collaboration, Edison has always adopted a policy that must in part be taken to explain his many successes. Some inventors of the greatest abilities, dealing with ideas and conceptions of importance, have found it impossible to organize or even to tolerate a staff of co-workers, preferring solitary and secret toil, incapable of teamwork, or jealous of any intrusion that could possibly bar them from a full and complete claim to the results when obtained. Edison always stood shoulder to shoulder with his associates, but no one ever questioned the leadership, nor was it ever in doubt where the inspiration originated. The real truth is that Edison has always been so ceaselessly fertile of ideas himself, he has had more than his whole staff could ever do to try them all out. He has thought cooperation, but no exterior suggestion. As a matter of fact, a great many of the Edison men have made notable inventions of their own, which their names are imperishably associated. But while they were with Edison, it was with his work that they were and must be busied. It was during this period of inventing a system that so much of systematic and continuous work with good results was done by Edison in the design and perfection of dynamos. The value of his contributions to the art of lighting comprised in this work has never been fully understood or appreciated, having been so greatly overshadowed by his invention of the incandescent lamp, and of a complete system of distribution. It is a fact, however, that the principal improvements he made in dynamo-electric generators were of a radical nature and remain in the art. 30 years bring about great changes, especially in a field so notably progressive as that of the generation of electricity. But different as are the dynamos of today from those of the earlier period, they embody essential principles and elements that Edison then marked out and elaborated as the conditions of success. There was indeed prompt appreciation in some well-informed quarters of what Edison was doing, evidenced by the sensation caused in the summer of 1881, when he designed, built, and shipped to Paris, for the first electrical exposition ever held, the largest dynamo that had been built up to that time. It was capable of lighting 1,200 incandescent lamps, and weighed with its engine 27 tons, the armature alone weighing 6 tons. It was then, and for a long time after, the eighth wonder of the scientific world, and its arrival and installation in Paris were eagerly watched by some of the most famous physicists and electricians of Europe. Edison's amusing description of his experience in shipping the dynamo to Paris when built may appropriately be given here. I built a very large dynamo with the engine directly connected, which I intended for the Paris Exposition of 1881. It was 1 or 2 sizes larger than those I had previously built. I had only a very short period in which to get it ready and put it on a steamer to reach the Exposition in time. After the machine was completed, we found the voltage was too low. I had to devise a way of raising the voltage without changing the machine, which I did by adding extra magnets. After this was done, we tested the machine, and the crankshaft of the engine broke and flew clear across the shop. By working night and day, a new crankshaft was put in, and we only had 3 days left from that time to get it on board the steamer, and had also to run a test. So we made arrangements with the Timnani leader, and through him with the police, to clear the streets, one of the New York crosstown streets, and line it with policemen, as we proposed to make a quick passage, and didn't know how much time it would take. About 4 hours before the steamer had to get it, the machine was shut down after the test, and a schedule was made out in advance of what each man had to do. 60 men were put on top of the dynamo to get it ready, and each man had written orders as to what he was to perform. We got it all taken apart and put on trucks and started off. They drove the horses with a fire bell in front of them to the French pier, the policemen lining the streets. 50 men were ready to help the stevedores get it on the steamer, and we were 1 hour ahead of time. This exposition brings us, indeed, to a dramatic and rather pathetic parting of ways. The hour had come for the old laboratory force that had done such brilliant and memorable work to disband, never again to assemble under like conditions for like effort. Although its members all remained active in the field, and many have ever since become associated prominently with some department of electrical enterprise, the fact was they had done their work so well they must now disperse to show the world what it was, and assist in its industrial exploitation. In reality, they were too few for the demands that reached Edison from all parts of the world for the introduction of his system, and in the emergency the men nearest to him and most trusted were those upon whom he could best depend for such missionary work as was now required. The disciples, full of fire and enthusiasm, as well as of knowledge and experience, were soon scattered into the 4 winds, and the rapidity with which the Edison system was everywhere successfully introduced is testimony to the good judgment with which their leader had originally selected them as his colleagues. No one can say exactly just how this process of disintegration began, but Mr. E. H. Johnson had already been sent to England in the Edison interests, and now the question arose as to what should be done with the French demands and the Paris Electrical Exposition, whose importance as a point of new departure in electrical industry was speedily recognized on both sides of the Atlantic. It is very interesting to note that as the earlier staff broke up, Edison became the center of another large body, equally devoted, but more particularly concerned with the commercial development of his ideas. Mr. E.G. Acheson mentions in his personal notes on work at the laboratory that in December of 1880, while on some experimental work, he was called to the new lamp factory started recently at Menlo Park, and there found Edison, Johnson, and Batchelor and Upton in conference. And Edison informed me that Mr. Batchelor, who was in charge of the construction, development, and operation of the lamp factory, was soon to sail to Europe to prepare for the exhibit to be made at the Electrical Exposition, to be held in Paris during the coming summer. These preparations overlap the reinforcement of the staff with some notable additions, chief among them being Mr. Samuel Insull, whose interesting narrative of events fits admirably into the story at this stage, and gives a vivid idea of the intense activity and excitement with which the whole atmosphere around Edison was then surcharged. I first met Edison on March 1, 1881. I arrived in New York on the city of Chester about 5 or 6 in the evening, and went direct to 65 Fifth Avenue. I had come over to act as Edison's private secretary, the position having been obtained for me through the good services of Mr. E. H. Johnson, whom I had known in London, and who wrote to Mr. U. H. Painter of Washington about me in the fall of 1880. Mr. Painter sent the letter on to Mr. Batchelor, who turned it over to Edison. Johnson returned to America late in the fall of 1880, and in January 1881 cabled me to come to this country. At the time he cabled for me, Edison was still at Menlo Park, but when I arrived in New York, the famous offices of the Edison Electric Light Company had been opened at 65 Fifth Avenue, and Edison had moved into New York with the idea of assisting in the exploitation of the light company business. I was taken by Johnson direct from the Inman steamship pier to 65 Fifth Avenue, and met Edison for the first time. There were 3 rooms on the ground floor at that time. The front one was used as a kind of reception room. The room immediately behind it was used as the offices of the president of the Edison Electric Light Company, Major S.B. Eaton. The rear room, which was directly back of the front entrance hall, was Edison's office, and there I first saw him. There was very little in the room except a couple of walnut roller-top desks, which were very generally used in American offices at that time. Edison received me with great cordiality. I think he was possibly disappointed at my being such a young man. I had only just turned 21, and had a very boyish appearance. The picture of Edison is as vivid to me now as if the incident occurred yesterday, although it is now more than 29 years since that first meeting. I had been connected with Edison's affairs in England as a private secretary to his London agent for about 2 years, and had been taught by Johnson to look on Edison as the greatest electrical inventor of the day, a view of him, by the way, which has been greatly strengthened as the years have rolled by. Owing to this, and to the fact that I felt highly flattered at the appointment as his private secretary, I was naturally prepared to accept him as a hero. With my strict English ideas as to the class of clothes to be worn by prominent men, there was nothing in Edison's dress to impress me. He wore a rather seedy black diagonal Prince Albert coat and waistcoat, with trousers of a dark material, and a white silk handkerchief around his neck, tied in a careless knot, falling over the stiff bosom of a white shirt, somewhat the worse for wear. He had a large wide-awake hat of the sombrero pattern then generally used in this country, and a rough brown overcoat, cut somewhat similarly to his Prince Albert coat. His hair was worn quite long, and hanging carelessly over his fine forehead. His face was at that time, as it is now, clean-shaven. He was full in face and figure, although by no means as stout as he has grown in recent years. What struck me above everything else was the wonderful intelligence and magnetism of his expression, and the extreme brightness of his eyes. He was far more modest than in my youthful picture of him. I had expected to find a man of distinction. His appearance, as a whole, was not what you would call slovenly. It is best expressed by the word careless. Mr. Insull supplements this pen picture by another, bearing upon the hustle and bustle of the moment. After a short conversation, Johnson hurried me off to meet his family, and later in the evening, about 8 o'clock, he and I returned to Edison's office, and I found myself launched without further ceremony into Edison's business affairs. Johnson had already explained to me that he was sailing the next morning, March 2nd, on the SS Arizona, and that Mr. Edison wanted to spend the evening discussing matters in connection with his European affairs. It was assumed, inasmuch as I had just arrived from London, that I would be able to give more or less information on this subject. As Johnson was to sail the next morning at 5 o'clock, Edison explained that it would be necessary for him to have an understanding of European matters. Edison started out by drawing from his desk a cheque-book and stating how much money he had in the bank, and he wanted to know what European telephone securities were most saleable, as he wished to raise the necessary funds to put on their feet the incandescent lamp factory, the electric tube works, and the necessary shops to build dynamos. All through the interview I was tremendously impressed with Edison's wonderful resourcefulness and grasp, and his immediate appreciation of any suggestion of consequence bearing on the subject under discussion. He spoke with very great enthusiasm of the work before him, namely, the development of his electric lighting system, and his one idea seemed to be to raise all the money he could, with the object of pouring it into the manufacturing side of the lighting business. I remember how extraordinarily I was impressed with him on this account, as I had just come from a circle of people in London who not only questioned the possibility of the success of Edison's invention, but often expressed doubt as to whether the work he had done could be called an invention at all. After discussing affairs with Johnson, who was receiving his final instructions from Edison, far into the night, and going down to the steamer to see Johnson aboard, I finished my first night's business with Edison somewhere between 4 and 5 in the morning, feeling thoroughly imbued with the idea that I had met one of the great master minds of the world. You must allow for my youthful enthusiasm, but you must also bear in mind Edison's particular gift of magnetism, which has enabled him during his career to attach so many men to him. I fell a victim to the spell at the first interview. Events moved rapidly in those days. The next morning, Tuesday, Edison took his new Fides Achates with him to a conference with John Roach, the famous old shipbuilder, and Added agreed to take the Etna Iron Works, where Roach had laid the foundations of his fame and fortune. These works were not in use at the time. They were situated on Gurrick Street, New York, north of Grand Street, on the east side of the city, and there, very soon after, was established the first Edison dynamo manufacturing establishment, known for many years as the Edison Machine Works. The same night, Insull made his first visit to Menlo Park. Up to that time he had seen very little incandescent lighting, for the simple reason that there was very little to see. Johnson had had a few Edison lamps in London, lit up from primary batteries, as a demonstration, and in the summer of 1880 Swan had had a few series of lamps burning in London. In New York, a small gas engine plant was being started at the Edison offices on Fifth Avenue, but out at Menlo Park there was the first actual electric lighting central station, supplying distributed incandescent lamps and some electric motors by means of underground conductors, embedded in asphalt and surrounded by a wooden box. Mr. Insull says, "The system employed was naturally the 2-wire, as at that time the 3-wire had not been thought of. The lamps were partly of the horseshoe filament paper carbon type, and partly bamboo filament lamps, and were of an efficiency of 95 to 100 watts per 16 cp. I can never forget the impression that this first view of the electric lighting industry produced on me. Menlo Park must always be looked upon as the birthplace of the electric light and power industry. At that time it was the only place where could be seen an electric light and power multiple arc distribution system, the operation of which seemed such successful to my youthful mind as the operation of one of the large metropolitan systems today. I well remember about 10 o'clock that night going down to the Menlo Park depot and getting the station agent, who was also the telegraph operator, to send some cable messages for me to my London friends, announcing that I had seen Edison's incandescent lighting system in actual operation, and that, so far as I could tell, it was an accomplished fact. A few weeks afterwards I received a letter from one of my London friends, who was a doubting Thomas, upbraiding me for coming so soon under the spell of the Yankee inventor. It was to confront and deal with just this element of doubt in London and in Europe generally that the dispatch of Johnson to England and of Bachelor to France was intended. Throughout the Edison staff there was a mingled feeling of pride in the work, resentment at the doubts expressed about it, and keen desire to show how excellent it was. Bachelor left for Paris in July 1881. On his second trip to Europe that year, and the exhibit was made which brought such an instantaneous recognition of the incalculable value of Edison's lighting inventions, as evidenced by the awards and rewards immediately bestowed upon him. He was made an officer of the Legion of Honor, and Professor George F. Barker cabled as follows from Paris, announcing the decision of the expert jury which passed upon the exhibits. "Accept my congratulations. You have distanced all competitors and obtained a diploma of honor, the highest award given in the exposition. No person in any class in which you were an exhibitor received a like award." Nor was this all. Eminent men in science, who had previously expressed their disbelief in the statements made as to the Edison system, were now foremost in generous praise of his notable achievements, and accorded him full credit for his completion. A typical instance was Mr. Du Moncel, a distinguished electrician who had written cynically about Edison's work and denied its practicability. He now recounted publicly in this language, which in itself shows the state of the art when Edison came to the front. All these experiments achieved but moderate success, and when in 1879 the new Edison incandescent carbon lamp was announced, many of the scientists, and I particularly, doubted the accuracy of the reports which came from America. This horseshoe of carbonized paper seemed incapable to resist mechanical shocks and to maintain incandescence for any considerable length of time. Nevertheless, Mr. Edison was not discouraged, and despite the active opposition made to his lamp, despite the polemic acerbity of which he was the object, he did not cease to perfect it, and he succeeded in producing the lamps which we now behold exhibited at the exposition, and are admired by all for their perfect steadiness. The competitive lamps exhibited and tested at this time comprised those of Edison, Maxim, Swan, and Lane Fox. The demonstration of Edison's success stimulated the faith of his French supporters, and rendered easier the completion of plans for the Société Edison Continentale of Paris, formed to operate the Edison patents on the continent of Europe. Mr. Bachelor, with Messrs. Acheson and Hippel, and one or two other assistants, at the close of the exposition, transferred their energies to the construction and equipment of machine shops and lamp factories at Ivry-sur-Seine for the company. and in a very short time the installation of plants began in various countries, France, Italy, Holland, and Belgium, etc. All through 1881, Johnson was very busy for his part in England. The first jumbo Edison dynamo had gone to Paris. The second and third went to London, where they were installed in 1881 by Mr. Johnson and his assistant, Mr. W. J. Hammer, in the 3,000 light central station on Holborn Viaduct, the plant going into operation on January 12, 1882. Outside of Menlo Park, this was the first regular station for incandescent lighting in the world, as the Pearl Street station in New York did not go into operation until September of the same year. This historic plant was hurriedly thrown together on Crown land, and would doubtless have been the nucleus of a great system, but for the passage of the English Electric Lighting Act of 1882, which at once throttled the industry by its absurd restrictive provisions, and which, though greatly modified, has left England ever since in a condition of serious inferiority as to the development in electric light and power. The streets and bridges of Holborn Viaduct were lighted by lamps turned on and off from the station, as well as the famous city temple of Dr. Joseph Parker, the first church in the world to be lighted by incandescent lamps. Indeed, so far as can be ascertained, the first church to be illuminated by electricity in any form. Mr. W. J. Hammer, who supplies some very interesting notes on the installation, says, "I well remember the astonishment of Dr. Parker and his associates when they noted the difference of temperature as compared with gas. I was informed that the people would not go into the gallery in warm weather, owing to the great heat caused by the many gas jets, whereas on the introduction of the incandescent lamp there was no complaint." The telegraph operating room of the General Post Office at St. Martin le Grand and Newgate Street near by was supplied with 400 lamps through the instrumentality of Mr. Sir W. H. Preece, who, having been seriously skeptical as to Mr. Edison's results, became one of his most ardent advocates, and did much to facilitate the introduction of the light. This station supplied its customers by a network of feeders and mains of the standard underground 2-wire Edison tubing conductors in sections of iron pipes, such as was used subsequently in New York, Milan, and other cities. It also had a measuring system for the current, employing the Edison electrolytic meter. Arc lamps were operated from its circuits, and one of the first sets of practical storage batteries was used experimentally at this station. In connection with these batteries, Mr. Hammer tells a characteristic anecdote of Edison. A careless boy, passing through the station, whistling a tune and swinging carelessly a hammer in his hand, rapped a carboy of sulphuric acid, which happened to be on the floor above the jumbo dynamo. The blow broke the glass carboy, and the acid ran down upon the field magnet of the dynamo, destroying the windings of one of the 12 magnets. This accident happened while I was taking a vacation in Germany, and a prominent scientific man connected with the company cabled Mr. Edison to know whether the machine would work if the coil was cut out. Mr. Edison sent the laconic reply, "Why doesn't he try it and see?" Mr. E. H. Johnson was kept busy, not only with the cares and responsibilities of his pioneer English plant, but by negotiations as to company formations, hearings before parliamentary committees, and particularly by distinguished visitors, including all the foremost scientific men in England, and a great many well-known members of the peerage. Edison was fortunate in being represented by a man with so much address, intimate knowledge of the subject, and powers of explanation. As one of the leading English papers said at the time, with equal humor and truth, "There is but one Edison, and Johnson is his prophet." As the plant continued in operation, various details and ideas of improvement emerged, and Mr. Hammer says, "Up to the time of the construction of this plant, it had been customary to place a single pole switch on one wire and a safety fuse on the other, and the practice of putting fuses on both sides of a lighting circuit was first used here. Some of the first, if not the very first, of the insulated fixtures were used in this plant, and many of the fixtures were equipped with ball insulating joints, enabling chandeliers, or electroliers, to be turned around, as was common with the gas chandeliers. This particular device was invented by Mr. John B. Verity, whose firm built many of the fixtures for the Edison Company, and constructed the notable electroliers shown at the Crystal Palace Exposition of 1882. We have made a swift survey of developments from the time when the system of lighting was ready for use, and when the staff scattered to introduce it. It will be readily understood that Edison did not sit with folded hands, or drop into complacent satisfaction the moment he had reached the practical stage of commercial exploitation. He was not willing to say, "Let us rest and be thankful," as was one of England's great liberal leaders after a long period of reform. On the contrary, he was never more active than immediately after the work we have summed up at the beginning of this chapter. While he had been pursuing his investigations of the generator in conjunction with the experiments on the incandescent lamp, he gave much thought to the question of distribution of the current over large areas, revolving in his mind various plans for the accomplishment of this purpose, and keeping his mathematicians very busy working on the various schemes that suggested themselves from time to time. The idea of a complete system had been in his mind in broad outline for a long time, but it did not crystallize into commercial form until the incandescent lamp was an accomplished fact. Thus, in January 1880, his first patent application for a system of electrical distribution was signed. It was filed in the Patent Office a few days later, but was not issued as a patent until August 30, 1887. It covered fundamentally multiple arc distribution. How broadly will be understood from the following extracts from the New York Electrical Review of September 10, 1887. It would appear as if the entire field of multiple distribution were now in the hands of the owners of this patent. The patent is about as broad as a patent can be, being regardless of specific devices and laying a powerful grasp on the fundamental idea of multiple distribution from a number of generators throughout a metallic circuit. Mr. Edison made a number of other applications for patents on electrical distribution during the year 1880. Among these was the one covering the celebrated feeder invention, which has been of very great commercial importance in the art, its object being to obviate the drop in pressure, rendering lights dim in those portions of an electric light system that were remote from the central station. Footnote 10. For further explanation of feeder patent, see Appendix. From these two patents alone, which were absolutely basic and fundamental in effect, and both of which were, and still are, put into actual use wherever central station lighting is practiced, the reader will see that Mr. Edison's patient and thorough study, aided by his keen foresight and unerring judgment, had enabled him to grasp in advance with a master hand the chief and underlying principles of a true system. That system, which has since been put into practical use all over the world, and whose elements do not need the touch or change of more modern scientific knowledge. These patents were not by any means all he applied for in the year 1880. which it will be remembered was the year in which he was perfecting the incandescent electric lamp and methods, to put into market for competition with gas. It was an extraordinarily busy year for Mr. Edison and his whole force, which from time to time was increased in number. Improvement upon improvement was the order of the day. That which was considered good today was superseded by something better and more serviceable tomorrow. Device after device, relating to some part of the entire system, was designed, built, and tried, only to be rejected ruthlessly as being unsuitable. But the pursuit was not abandoned. It was renewed over and over again, in innumerable ways, until success had been attained. During the year 1880, Edison had made application for 60 patents, of which 32 were in relation to incandescent lamps, 7 covered inventions relating to distributing systems, including the 2 above particularized, 5 had reference to inventions of parts, such as motors, sockets, etc., 6 covered inventions relating to dynamo-electric machines, 3 related to electric railways, and 7 to miscellaneous apparatus, such as telegraph relays, magnetic ore separators, magneto-signaling apparatus, etc. The list of Mr. Edison's patents, see appendices, is not only a monument to his life's work, but serves to show what subjects he was working on from year to year since 1868. The reader will see from an examination of this list that the years 1880, 1881, 1882, and 1883 were the most prolific periods of invention. It is worthwhile to scrutinize this list closely to appreciate the wide range of his activities. Not that his patents cover his entire range of work by any means, for his notebooks reveal a great number of major and minor inventions for which he is not seen fit to take out patents. Moreover, at the period now described, Edison was the victim of a dishonest patent solicitor, who deprived him of a number of patents in the following manner. Around 1881-82, I had several solicitors attending to different classes of work. One of these did me most serious injury. It was during the time that I was developing my electric lighting system, and I was working and thinking very hard in order to cover all the numerous parts, in order that it would be complete in every detail. I filed a great many applications for patents at that time, but there were 78 of the inventions I made in that period that were entirely lost to me and my company by reason of the dishonesty of this patent solicitor. Specifications had been drawn, and I had signed and sworn to the application for patents for these 78 inventions, and naturally I supposed they had been filed in the regular way. As time passed, I was looking for some action of the Patent Office, as usual, but none came. I thought it very strange, but had no suspicions until I began to see my inventions recorded in the Patent Office Gazette as being patented by others. Of course I ordered an investigation, and found that the patent solicitor had drawn from the company the fees for filing all these applications, but had never filed them. All the papers had disappeared. However, and what he had evidently done was to sell them to others, who had signed new applications and proceeded to take out patents themselves on my inventions. I afterwards found that he had been previously mixed up with a somewhat similar crooked job in connection with telephone patents. I am free to confess that the loss of these 78 inventions has left a sore spot in me that has never healed. They were important, useful, and valuable, and represented a whole lot of tremendous work and mental effort, and I had had a feeling of pride in having overcome through them a great many serious obstacles. One of these inventions covered the multipolar dynamo. It was an elaborated form of the type covered by my patent number 219393, which had a ring armature. I modified and improved on this form, and had a number of pole pieces placed all around the ring, with a modified form of armature winding. I built one of these machines and ran it successfully in our early days at the Gurrick Street shop. It is of no practical use to mention the man's name. I believe he is dead, but he may have left a family. The occurrence is a matter of the old Edison Company records. It will be seen from an examination of the list of patents in the appendix that Mr. Edison has continued year after year adding to his contributions to the art of electric lighting, and in the last 28 years, 1880 through 1908, has taken out no fewer than 375 patents in this branch of industry alone. These patents may be roughly tabulated as follows: incandescent lamps and their manufacture, 149. Distributing systems and their control and regulation, 77. Dynamo electric machines and accessories, 106. Minor parts such as sockets, switches, safety catches, meters, underground conductors and parts, etc., 43. Quite naturally, most of these patents cover inventions that are in the nature of improvements or based upon devices which he had already created, but there are a number that relate to inventions absolutely fundamental and original in their nature. Some of these have already been alluded to, but among the others there is one which is worthy of special mention in connection with the present consideration of a complete system. This is patent number 274290, applied for November 27, 1882. It is known as the three-wire patent. It is described more fully in the appendix. The great importance of the feeder and the three-wire inventions will be apparent when it is realized that without them it is a question whether electric light could be sold to compete with low-priced gas, on account of the large investment in conductors that would be necessary. If a large city area were to be lighted from a central lighting station by means of copper conductors running directly therefrom to all parts of the district, it would be necessary to install large conductors or suffer such a drop of pressure at the ends most remote from the station as to cause the lights there to burn with a noticeable diminution of candle power. The feeder invention overcame this trouble, and made it possible to use conductors only 1/8 the size that would otherwise have been necessary to produce the same results. Still further economy in cost of conductors was effected by the three-wire invention, by the use of which the already diminished conductors could still further be reduced to 1/3 of this smaller size, and at the same time allow for the successful operation of the station with far better results than if it were operated exactly as at first conceived. The feeder and three-wire systems are at this day used in all parts of the world, not only in central station work, but in the installation and operation of isolated electric light plants in large buildings. No sensible or efficient station manager or electric contractor would ever think of an installation made upon any other plan. Thus, Mr. Edison's early conceptions of the necessities of a complete system, one of them made even in advance of practice, have stood firm, unimproved, and unchanged during the past 28 years, a period of time which has witnessed more wonderful and rapid progress in electrical science and art than has been known during any similar art or period of time since the world began. It must be remembered that the complete system in all its parts is not comprised in the few of Mr. Edison's patents, of which specific mention is here made. In order to comprehend the magnitude and extent of his work, and the quality of his genius, it is necessary to examine minutely the list of patents issued for the various elements which go to make up such a system. To attempt any relation in detail of the conception and working out of each part or element, to enter into any description of the almost innumerable experiments and investigations that were made, would entail the writing of several volumes, for Mr. Edison's close-written notebooks covering these subjects number nearly 200. It is believed that enough evidence has been given in this chapter to lead to an appreciation of the assiduous work and practical skill involved in inventing a system of lighting that would surpass, and to great extent, in one single quarter of a century, supersede all the other methods of illumination developed during long centuries. But it will be appropriate, before passing on, to note that on January 17, 1908, while this biography was being written, Mr. Edison became the 4th recipient of the John Fritz Gold Medal for Achievement in Industrial Progress. This medal was founded in 1902 by the professional friends and associates of the veteran American ironmaster and metallurgical inventor, in honor of his 80th birthday. Awards are made by a board of 16 engineers, appointed in equal number from the 4 great national engineering societies: the American Society of Civil Engineers, the American Institute of Mining Engineers, the American Society of Mechanical Engineers, and the American Institute of Electrical Engineers, whose membership embraces the very pick and flower of professional engineering talent in America. Up to the time of the Edison Award, 3 others had been made. The first was to Lord Kelvin, the Nestor of physics in Europe, for his work in submarine cable telegraphy and other scientific achievement. The second was to George Westinghouse for the air brake. The third was to Alexander Graham Bell for the invention and introduction of the telephone. The award to Edison was not only for his inventions in duplex and quadruplex telegraphy and for the phonograph, but for the development of a commercially practical incandescent lamp, and the developments of a complete system of electric lighting, including dynamos, regulating devices, underground system, protective devices, and meters. Great has been the genius brought to bear on electrical development. There is no other man to whom such a comprehensive tribute could be paid. End of chapter 14.